So it's really great to be here, and like I was lucky to hear first what you are doing, and the first thing that came to my mind is really that we are doing quite similar things, like a bit different, but we have quite much maybe same aspects in our projects. But um, so our project is, as it was kindly introduced, it's design, manufacturing, and validation of EcoCycle electric traction motor, and the abbreviation is VOLTCAR. And if we move forward a bit, I would like to first introduce the project data, like the key figures of our project. So we started this activity in February this year. So it means that we have been working about 8.5 months on the developments. The duration of the project is 3 years, and we applied almost the total or the maximum budget that was available for funding in this call. And if we take a look at the project partners, we have 12 partners from 6 European countries, 7 of which are industrial partners and 5 are research partners. And we sort of have this kind of clusters from Finland, from Belgium, Germany, and Slovenia. We also have one partner from Ukraine, the University of Kremenchuk, and then we have our fantastic communication and dissemination partner from the Cyprus. And from Finland, if I go back a bit, we have Danfoss Editron, who is working on the motor and also like the motor manufacturing and the inverter to control it. VTT, we are a research and technology organization contributing on the eco design and contributing on the validation of the motors. Then we have the Lappeenranta University from Finland as well. They are doing a great job on the design of the motors. If we move a bit south, we go to Germany. We have Bosch. Bosch is very interested on the digital technologies for the new traction motors. We have BorgWarner, who is also contributing to the motor design and manufacturing activities. We have Siemens. Then we move a little bit west. We go to Belgium. We have Siemens, who is doing the digitalized technologies for the motor and bringing the digital twin of the motor to alive. We have also KU Leuven from Belgium, who are working on the noise, vibration and harshness topics and all sorts of mechanical aspects of the motor development and validation. Then we go to Slovenia. We have Hydria, who will be providing the electrical steel sheet stacks for the prototype motors. We have Collector from the magnet side, and then we have University of Ljubljana, who is working a lot on the design methodologies and the digitalized motor technologies. And if we think about the challenge that was set for all the projects funded under this call, so we all know that, okay, electrification is progressing very rapidly, and it's not the electrification of the transportation only, but it's the electrification of industries, and all this needs a lot of like clean electrical energy to be really sustainable in the end. And if we think about like the present traction motors, or for instance the generators in wind turbines, all of those use a lot of like rare earth materials, like namely neodymium iron boron magnets. And of course this is highly problematic because these magnets are like exported and they are expensive. And if we look at the graphs, how the demand for the permanent magnets from the different sectors is developing in the near future, there might be a really a problem with the supply of the material. So something needs to be done, and something needs to be done on the component level, and like also on the electric traction motors, as you have heard very nicely. Our colleagues from the other projects already explained their approaches, how to do that. And on the other hand, because the permanent magnets are bringing such a good performance for the motor, it sets a pretty huge like challenge for us to reduce the amount of magnets and on the same time improve the performance, and on the same time also meet all the criteria that the automotive sector is putting for us, like related on the cost and reliability and integrability. So this is a really, really huge challenge for us all to meet the criteria set in the call. And in order to tackle this challenge, we have set 4 distinct objectives for our VOLTCAR project. So we want to, of course, like the key delivery of the project are those compact and efficient traction motors, which are like catering the mass market of the vehicles, the passenger cars and the vehicles. But that's not all, and we need to do a quite of a broad. We need to take a quite of a broad approach to this whole topic to tackle this first objective even. And one of the other key aspect in our project is that we also, as the others in the room, are developing these circular technologies or eco-design technologies for the motors, and this is exactly what we are doing as well. Of course, we need to demonstrate in practice that we are successful, the motors are as they are expected to be, and we also need to provide a digitalized version of the motor at the end of the project to for instance, to operate it the optimal way during its life cycle, to dismantle it correctly, to use the parts that can be used after it has been taken out of the primary first life use, what to do with the materials, where to put them. So this third objective supports that one as well. And then as a fourth item, we are planning this kind of a comprehensive testing and validation campaign of the VOLTCAR motors and all the related systems that are involved. And if we take a look at the specific targets, okay, the power density requirement, it comes directly from the call text. We are also targeting at a very high recyclability rate of especially the permanent magnet materials. We want to strengthen the European technology leadership on this topic. We are going towards elevated voltages. Of course, we have at market those 800 volt powertrains already, but this was approach that we took, and I noticed that is an approach that many of the projects in this room took. Of course, we aim at reduction of the losses, and we aim at a reduction of the cost. And let's take a look at the VOLTCAR solution. So we are going with the radial flux motor topology. We are focusing on the permanent magnet assisted synchronous reluctance motors with the key aim to really drastically reduce the amount of the rare earth materials used. And like in order to succeed in all of these different goals that have been set for our project, we really try to also to design and optimize it throughout the life cycle with digitalized and physical approaches. And here on the table, you can see some of the key figures of our motor developments. So the rated speed will be around 10,000 to 12,000 RPMs, and the maximum speed will be around 20,000 RPMs to 24,000 RPMs. The voltage I mentioned already. We are developing 2 variants of the motor. We are doing a smaller one, and then we are doing a bigger one, the 120 kilowatt continuous power motor. The amount of rare earth material is 300 grams, so really little, and the power density figures and specific power, they came directly from the call, and this is of course our really primary target as well. The cooling, the thermal management was mentioned many times in the presentations, and indeed it's one of the key aspects in our activities as well, because if you don't manage the losses and the heat from that, you simply cannot reach the other objectives of the call. We also go with efficient liquid cooling. It's a quite fancy one, and let's see how it will be in the end. Then if we take a quick look on how the project is going forward and what kind of steps we have been taken towards the objectives. So if we first assess the objective 1, so we have also made the key design choices for the first prototypes, and now we are in the process of engineering the manufacturability and the manufacturing, all the related aspects relating to the manufacturing and purchasing the components, purchasing the materials and such. And we are also like relying on the very modern manufacturing technologies, for instance, the backlash lamination stacks, hairpin windings, and things like that. And the whole assembly will then have also a gearbox to have the torque on a correct level for the wheels. And then we have a silicon carbide a semiconductor inverter for which we are developing an energy consumption minimizing control algorithm. And I also wanted to put some key figures for our motor developments on the table. So you can see the number of ball pairs, the faces, the key dimensions, and really the mass of the motor needs to be extremely small to meet the power density requirements. And these numbers have been now presented for the bigger 120 kilowatt motor. Moving forward, we also had the objective 2, which is the eco-design aspect. And in this specific, what kind of steps we have made towards meeting this objective. So we are actually quite a lot putting an effort on the design side and also on the technological development side in order to be able to recycle the magnets that are put in the motors the most efficient way. And for that purpose, we think that if we could reuse the magnets as such after they have been taken from the first use or from the electric traction motor, as such, that could be most energy efficient way for the recycling. That is like the reusing the magnets. And we are now considering different kind of techniques, how we could make it possible to remove the magnets intact, because they might be too brittle to be removed without any additional mechanical support. And we are now assessing different means of encapsulating the magnets to enable the objective of reusing. And we have done some experiments, and you can see that some results on the right hand side. The power given like denotes 1 power used in the process of preparing the encapsulation. And we also see that different aspects like in the manufacturing and choice of the materials, they affect a lot in which condition the magnets are after the encapsulation, but this is something that we are now working really hard on. Then we had the objective 3. So this is quite a lot on the digitalization of the motor and designing the different approaches or developing the different approaches to assess the motor, not only when we design it, but also when we operate it, and also when we produce it, and when we like dismantle the motor or its parts. So we have quite like this kind of inclusive campaign of including the different phases of the motor lifetime in a logical way and trying to support the development in the different phases the best we can. Then we have the steps towards the objective 4. So we have, of course, as the other projects, we have a rather big work package on the measurement and validation of the different prototype motors. And this work package has just begun, and we are now detailing the plan, what we want to measure, where we want to measure, who is measuring and what not. But also we have initiated in parallel, before the motors are ready for experimentation, this kind of a smaller like validation preparation activities in order to succeed with the actual measurements with the VOLTCAR motors, so that, for instance, we can really little bit explore beforehand if this works and if this does not work, and what should be taken into account when we really have the VOLTCAR motors ready for action. Because we want to use this kind of an hardware in the loop methodologies as well to simulate the vehicle and drive the VOLTCAR motors according to the vehicle specifications and requirements. And if we go quickly to the status of today, so the aim is to finalize the smaller 50 kilowatt motor prototypes during summer 24. Then we would initiate, after the motors are ready, we will initiate the measurements, and we hope that we can use these results to perfect the second bigger prototypes, which should be ready in the summer 25. Of course, then we have the big measurement campaign where we produce the information how well we met the objectives, and we also disseminate and communicate broadly the results of our project. And still a couple of more slides. Sorry, I'm a bit taking bit much time, but only 2 slides more. So if we then take a look at the impact, so the market is needing, the mass market of the vehicles is really needing traction motors which are inexpensive, with reduced costs. They are energy efficient and with smallest possible carbon footprint. And what we are like producing in the VOLTCAR project is that we bring this next generation permanent magnet assisted synchronous motor. We wish to introduce like optimized manufacturing and assembly processes for these next gen motors. We make a demo of the reduction of the rare earth materials and also like the recyclability of those materials. We provide a digital platform for the whole life cycle of the motor, and we bring the demos of the motors combined with a virtual vehicle. And the outcomes that we are targeting at is that we wish that the VOLTCAR technologies could be adopted by the tier partners of the project. We wish to bring the cost reduction of the motors and the electric vehicles, and we wish that we could bring new jobs to Europe. We could maybe some new companies could be established based on this work, or some further work and things like that. And as we all know, this work that we are doing, it actually can have a really significant impact in the future. It can result in the power savings. It can be like hugely like reduced like emissions. We can save like the virgin material that is needed in the permanent magnets, and like really like it can accelerate the integration, like accelerate of the electrification of the cars and vans with a reduced environmental impact, and also improving the charging capabilities of the future vehicles, and also like hopefully like this kind of a commercialized like really taking these recyclability and the tools for that into use in the future as well, like elevating this kind of activities on an industrial scale as well. And the very last slide that I have is this one. So our methodology is founded on 4 pillars: design and prototyping, eco-design approach, digitalized motor, and the validation. And I think this is a good place to stop my presentation. And I want to thank you very much for your attention, and let's keep in touch. It would be nice to cooperate with you all. Thanks a lot.